Hi everybody, Lamont Sanford here, and this pre-calculus lesson is on quadratic equations. You saw a lot of this in Algebra 1 and Algebra 2. Let's go ahead and take care of the board problem first. State the degree and the leading coefficient of f of x equals x squared plus 9x to the fourth minus 5x plus 3. Okay, this 4 is my degree, so because it's 9x to the fourth, it's the highest power, and the number in front of your degree maker is your leading coefficient. So 4 is the degree, 9 is the leading coefficient. Okay, determine whether 3 is a root of this polynomial equation. So we're going to plug in 3, and if it equals 0, then yes, it is a root. If it doesn't equal 0, then no, it's not a root. And so when you plugged it in, I didn't get 0, so the fact is it's not a root right there. Okay, so write a polynomial equation of least degree. Okay, we did this in our last lesson, you guys, so I'm going to make this a factor. X minus 3i is a factor. X plus 3i is a factor. X minus 4 is a factor. Equals 0. Don't forget your equals 0. I'm going to FOIL all those out. Okay, these guys are conjugates of each other. Conjugates always FOIL out to a difference of squares. Notice this is x squared. This is 3i squared, so that goes there. Don't forget I squared equals negative 1, so negative 9i squared becomes plus 9. Then I FOILed these two guys out, and I got this guy right here and cleans up to be this one. So here's that one right there. And finally, number 4, find the roots of this guy. This one, the only way you can so far until we get to the rational roots theorem, which is later, is to factor this, you guys. So you can GCF out of these two guys at 2x squared, and when I pull a 2x squared out, I'm left with 2x plus 1. Out of these two guys, I can pull an 8 out, and I'm left with 2x plus 1. Notice both these guys have a 2x plus 1, so I made them 2x minus 1, sorry. And then so I pulled the 2x minus 1 out, and I'm left with the blue stuff, 2x squared plus 8. That's what goes right here. Then I can set this factor equal to 0, divide by 2, and square root, you get plus or minus 2i. Over here you get 1/2. So there's 3 roots, 2i, negative 2i, and 1/2. I knew there's 3 roots because it was cubed. All right, so let's go ahead. Quadratic equations, you guys. And part A, if a plus bi is a root, then so is a minus bi. And a plus bi and a minus bi are conjugates of each other. So if you have an imaginary number in there, it's called a complex number actually, then the conjugate's also a root also. Okay, the discriminant, remember this in the quadratic formula, the b squared minus 4ac, that part in there, that's called the discriminant. That's what goes inside the radical right there. So the discriminant tells us what's called the nature of the roots. If you just look at the b squared minus 4ac, if it's less than 0, that means there's no real roots, okay? And they're distinct conjugate imaginary roots, okay? Roots are zeros. Okay, so it's just a parabola, you guys. It never crosses the x-axis. So that's it. If it has a root, it goes through the x-axis, but sometimes they don't. So that's when the b squared minus 4ac is a negative number right there. Okay, if it equals 0, there's exactly one root, and there's a parabola that intersects it in one spot. And if it's greater than 0, whoops, this should be greater than 0 right here. This should be greater than 0. Greater than 0. Golly, I can't make it through without... Okay, if it's greater than 0, then there are two distinct roots, okay? D-I-S-T. D-I-S-T. Sorry. Golly. Okay. Two distinct roots. I'm going to have those same mistakes right there. Okay, so there's a parabola that where it's crossing the x-axis in two spots, you guys. Okay, so if it's greater than 0, then there's two distinct roots. Let me fix that up. Sorry. Okay, so here we go. So find the discriminant and describe the nature of the roots of the equation. Okay, so here's a quadratic equation. Notice A is the 2, B is the 11, C is the negative 21. So I just plug in B squared minus 4AC. So 11 squared minus 4 times A times C, and I get 289. Okay, so there's the discriminant because it says find the discriminant. And since that's positive, that means there's two real roots. Okay, so there's two answers. Okay, this one. Okay, A is 1, B is negative 4, C is 15. So when you do B squared minus 4AC, you should get negative 44, so it's negative, so there's no real roots. Okay, so the quadratic formula, okay, remember this from the quadratic formula. If you have this equation, ax squared plus bx plus c equals 0, the solutions are, and here's a goofy way. I've learned this about 20 years ago, you guys. It's silly enough to try and remember. So So just think of this. Some negative boy couldn't decide, plus or minus, couldn't decide on whether to go to a radical party or to B square and miss out on 4 awesome chicks. The party was over at 2 a.m. Okay, there's one way. There's another way. I don't want to sing it to you. It just take too much time. But x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. Memorize that, you guys. You're going to need to know that. Okay, so solving quadratics. If you can factor it, that's the best way to solve quadratics, you guys. Set the factors equal to 0. Okay, it's the quickest, most efficient way. I have students that want to use the quadratic formula all the time, and no offense, but you guys suck at that. Me too, because you guys lose the negatives. There's too many numbers that gets involved with that, and you guys, if you're not careful, and I'm not careful, you can see in my lessons, I'm changing them all the time. I make mistakes all the time. I use that as a last result. And if you can't factor it, then completing the square works, and I have some examples on how to complete the square. Complete the square is the bomb, you guys, if A is 1 and B is an even number. If it's not either one of those, see like that one, see how A is 1 right there and B, that's B, that's an even number? That's dynamite to complete the square with. And it doesn't factor because there's no factors of 15 that add to negative 12. So I would use that one to complete the square, and I will in a second. So otherwise, if you can't factor it, or if A is not 1 and or B is not an even number, I'd use the quadratic formula. I do that as a last result. So solve these guys by completing the square. Okay, so here it is right here. So this is how you do it, you guys. You got to get rid of that C first. So I'm going to take away that plus 15 and put it on the other side. And then the next part is I take half of this 12. Half of 12 is 6. And then I square that. 6 squared is 36. So I add 36 to both sides. Okay, 36 came from half of that number squared. All right, and then you factor that. So this side factors to x minus 6 squared. This sign is always this sign right here. Okay, and then you go ahead and add those numbers. You get 21. And then if I have a square on the left and I square root both sides, don't forget your plus or minus, you guys. And then plus 6 to both sides, you get 6 plus or minus the square root of 21. Completing the square works just dynamite if A is 1 and that's an even number. This goes super fast, you guys. Watch. Here we go again. Okay, notice there's no factors of 10 that add to 2, so I'm going to add out 10. So I'm going to subtract 10 on both sides. Okay, and then I'm going to take half of 2, which is 1. 1 squared is 1, so I add 1 to both sides. Okay, this side factors to square root x squared. Square root 1 goes in there. This sign goes in the middle, and negative 10 plus 1 is negative 9. Square root both sides. Don't forget your plus or minus, and the square root of negative 9 is 3i, and then I subtracted 1 from both sides, and I get that right there. Okay, nice and easy. Okay, so let's solve this guy. Okay, now it just says solve. It doesn't say solve by completing the square or nothing. Are there any factors of 8 that add to negative 6? Heck yeah, negative 4 times negative 2. So that factors, you guys, x minus 4, x minus 2. So you set the factors equal to 0 and you get 4 and 2. Factoring's the bomb on solving quadratics. Okay, what about this guy? Any factors of 15 that add to negative 4? No, so I would complete the square with this one. Add out the 15. Take half of 4, which is 2. 2 squared is 4. So there I added that red 4 to both sides. This side factors to x. This sign goes here. X minus 2 squared equals 11. And square root both sides. And then don't forget square root of negative is I root 11. So this should be a positive 2. Whoops, there's another mistake, you guys. It should be a positive 2 right there. Okay, that's going to throw me off just a little bit. Let's see, that should be a positive 2. Okay, so 2 plus or minus I root 11. All right, okay, this one right here. Okay, this one, a lot of kids want to use the quadratic formula, but watch this, you guys. What I do is I multiply those outer two numbers to see if it factors. That gets me negative 12. Are there any other factors of negative 12 that add to this negative 1? Yes, negative 12 also equals 3 times negative 4. So I'm going to rewrite this polynomial, 6x squared minus x minus 2, and replace this negative x with plus 3x minus 4x. And then what I can do is factor it by grouping. See, there's my negative x right there. And then I'm going to factor by grouping. I'm going to group these two guys together and pull a 3x out. And then so I'll group the other two guys together and pull a negative 2 out. And you have a common factor of 2x plus 1. So pull the 2x plus 1 out, and you're left with the blue stuff. Then you can set those factors equal to 0 and solve. Okay, let's try this one. Do it again. 15 times 4 is 60. Factors of 60 that add to this are negative 10 times negative 6. And then it just factors, and you get Factor by grouping again, you get 2/3 or 2/5. You can get those same answers with the quadratic formula. I highly recommend factoring it first though. Okay, this one doesn't factor. I would go ahead and use the quadratic formula, you guys, and just make sure you're checking your work, 'cause you guys lose your negatives all the time. Me too.